Alrighty, as promised, I have some examples for you for 2.1, and this will help you kind of go through each of the two types. Have your chart handy if you still need it. It is always smart to know what to expect. So I'm looking at this and I'm seeing that it's a quadratic and I'm seeing that it's positive a. So I am expecting a parabola opening up when I start this problem. My a value is a 3, my b value is, that's a lie, my a value is a positive 1 in front of the x squared, my b value is a negative 3, and my c value is a negative 10. So when I go to do my vertex, I need to remember that to find that x coordinate, I'm taking the opposite of b over 2 times a. So I'm going to end up with 3 halves, 1.5, whatever floats your boat. I don't really care. It's possible that 1.5 will make your life easier because it's easier to find when you go to graph it. To find the y coordinate, I need to just go immediately into my function and plug in what I got for x. Now, again, we're in honors pre-calc, so it sure would be nice if you always got 2s and 1s, but you don't. We sometimes get 1.5. When you buzz that through your calculator or your brain, whichever one is more accurate and faster, you should get negative 12.25. So that's really annoying because it's going to be off my paper, but whatevs. So I'm going to go to 1.5 and then down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and a half. Oh, I'm sorry, a quarter. So I'm going to make my blob nice and big. That is going to be my vertex. Awesome. Okay, so then my axis of symmetry is like a no-brainer. My axis of symmetry always has the equation x equals the x coordinate because it needs to be a vertical line and it needs to go through my vertex. So the only way it's going to hit that vertex is if it has the proper x coordinate. So this is my axis of symmetry. And now my parabola, every point will have a partner on the other side that matches it. So it helps me provide the symmetry that makes it easier to graph. Okay, let's do the easy thing first. Y-intercept, remember you need to plug in x equals 0. So I would have 0 squared minus 3 times 0 minus 10, or you just happen to remember that it's always going to be 0 and then the c value, which for me is going to be down 1, 2, 3, 4, 10. And then I'm going to go 1.5 to the other side, and then that will be its matching pair. It looks like a little face. Okay, then I also am supposed to find my x-intercepts. Okay, looking at this, since it's a parabola opening up, I expect to see 2. It's going to cross in 2 spots. So if I look at my chart, my 2 ways to find that are to set it equal to 0 and then either factor or use quadratic. So I practiced factoring the other day and now I'm really good at it. I'm looking for ways to make 10, but they also have to subtract to be 3. So I'm going 5 and 2. I need the 3 to be negative, so I'm doing this little thing. But that will actually make my x-intercepts be negative 2 and positive 5, sorry, because I need them to be the zeros. What would make each thing 0? So this would be a negative 2 for a 0. This would be a positive 5 for a 0. So that's helpful because when I go over to my graph, I can go to negative 2 and draw that accurately, and then 1, 2, 3, 4, 5 and draw that in. And then when I connect my x-intercepts down through my y-intercept, hit the vertex, come back up, and then stay perfectly still so that Notability helps me look like I can draw better than I can, then I'm done. Okay, that is standard. Hopefully that rings some bells from last year. Vertex form, easy peasy finding the vertex. Keep in mind that this would go left 2, down 1, and it's going to be flipped over. So I'm thinking negative a, and I'm expecting this when I'm done. So this is an eyeball activity. If you move to the left 2 and down 1, your vertex is going to be at negative 2, negative 1. So like the chart says, I'm using the opposite of what's in here and then this one as is. Okay, axis of symmetry is always easy peasy. I write x equals because it's a vertical line, and then I steal my x coordinate from the vertex. Because what I know is that at negative 2, negative 1, that's my vertex. My axis of symmetry has to come down the middle. So that's going to be x equals that same value. Now, think about this, or don't think about this. Let's go ahead and start, and then we'll think about it afterwards. To do x-intercepts according to the chart, I need to set it equal to 0, and then I'm just copying the problem from up above. And then I'm supposed to solve using square roots. Well, to do square roots, I have to get rid of everything but the square. So I add 1 to the other side. The last thing you should do is distribute that negative. It's like having a -1 out front. So I'm going to divide that out. So now I'm at -1 equals x plus 2 squared. So the next thing I should do is introduce a square root, but sad face, you can't. Because on this side, it's asking you to take the square root of a negative. So let's think about it. I'm not getting an answer. Look at where your vertex is. It's right here. Think about what you knew going into this. Your parabola is supposed to open down. So it makes sense to me that there aren't any x-intercepts, because if my parabola has a vertex right there and the vertex is a max, it's not going to go above that and it's not going to cross the x-axis. Now, it'll still cross the y-intercept. And to do that, I do what I always do, and that is plug in x equals 0. So I go to my original function, and I put a 0 where there used to be an x. 0 plus 2 is actually still 2. And then be careful. Squaring the 2 makes it 4, but the negative is out front. And hopefully we're not going to still argue about positives and negatives at this level. PEMDAS says I have to do this first and get a 4, then I multiply it by that -1 that's technically sitting out front. So I am getting 0, -5. So that's going to be down 1, 2, 3, 4, 5. Since that's 2 over from my line of symmetry, then 2 over from there is going to be another matching partner point. And that actually is all I'm going to get without plugging more numbers in that I don't feel like doing. So that's good enough to guide my parabola, and it looks like I expected it to look. So the last skill on our chart was to change it to standard form. So I'm going to take my -x plus 2 squared and think of it as this. And I'm going to do what my notes say. I'm going to go ahead and FOIL this. See, isn't this fun? You're just using all of your Smarticus, all the things you've learned forever. Then I'm supposed to distribute. So again, keep in mind a negative out front is like distributing a -1. So everybody on the inside there is going to change signs. And then I'm going to just combine those last numbers. So my function in standard form will be -x squared, which still makes sense because it's flipped upside down, minus 4x minus 5, which also makes sense because that did turn out to be my y-intercept. So if I went through and did the opposite of b over 2a and all that business to find my vertex, these two would be the same. And if I'm taking a test and it's worth 100 points because my math teacher is mean, I would go ahead and put that into my calculator. I would type it in maybe as y1 for this function, the one that was given, and then type this one in as y2. They should be exactly the same. Like they should graph right on top of one another. Okay, so you always have to apply your knowledge, and if you're in physics, you're going to do these types of problems using similar formula. Actually, it will be a quadratic, and it'll have a gravitational constant in it. So this one is in feet, and it says the height of a ball thrown by Jerry, of course, is given by blah, blah, blah. In my perfect world, they would have used f of x, but nobody cares what I think. Where x is the horizontal distance in feet from where the ball is thrown. Okie doke. Graph the path of the ball in your calculator, on your calculator, and sketch a picture. Okay, so be smart. You have to use a window that makes sense. You have to start getting a handle on how to utilize the window, or you're not going to see the right thing if you're not looking out the right window. So x is representing feet forward from where it was thrown. So it doesn't make sense to have your x-min be negative. I'm going to go ahead and start 0, which will be right where it was thrown initially. I have no idea how far forward it's going to go, but I have actually done this problem, so I'm going to go ahead and put x max. X scale is what you're counting by. So who cares? You're not making the graph. Let your graph do it however it wants. And that's going to be going forward. So I'm basically going from 0 to 30 feet, 10, 20, 30. And then for the height, like how high this gets, that's going to be my y's. So again, it doesn't make sense to go less than 0, and then because that's going to be the ground. And then I don't have a clue how far it's going to go, but through experience, I decided that 20 was good, and you can let it count by whatever it wants. 1s, 2s, I don't care. So go ahead and take the time to graph it on your calculator, practice it. Because watching me and being like, ooh, I'm just going to copy her graph, that's great until you don't know how to do it anymore. So I'm not going to wait. You can pause the video. I got stuff to do, like go to bed. So let's pretend this is 4. This is where your graph should start. And the reason it's starting there is that that is my y-intercept. How do I know? Because it's right here. This is in standard form. So that's going to be at 4. And then I see it kind of goes like this. If you used this window, it doesn't hit right at 30. Okay. So how high, first of all, in calculus too, and we're pre-calc, so we're going to start thinking that way. Think about what the question's really asking you. It's asking you a math question about the thing you're learning right now. So when it says how high is the ball when it leaves Jerry's hand, well, when it leaves Jerry's hand, x is 0. The distance forward is 0. It hasn't gone forward. And so it's asking you basically for the y-intercept. And so that would be 4 feet. And you can plug in 0 if you want, or you can find it on your graph, but you can also use your big brain and go, oh, wait, it's in standard form, so my y-intercept is 4. What is the max height? Think about what that means. Your max height is going to be wherever the vertex is. Now, the vertex has an x and a y coordinate. Which of those represents height? Hopefully, you're screaming, why? Maybe not screaming. So this is asking you for v sub y. So you can do that one of 2 ways. You can find v sub x in your brain using the opposite of b over 2a. Or since they had you graph this on your calculator, you can do second trace max. Because we had a negative a, our vertex is a max. You are not looking for the x coordinate. It didn't ask you how far forward it was when it reached max height. It asked you what the max height is. So if you do that properly, you should get 16, and everything in this graph is measured in feet. Practice it. Know how to do left bound, right bound, and have it find your max for you. How far from Jerry does the ball strike the ground? Okay, strike the ground. What does that mean? Striking the ground means it has landed. It means its height, or y, is 0. So this is asking for an x-intercept. Now, if you use your big brain, this is an upside down parabola. There's another part back here, and that would be one of our zeros, but that one doesn't make sense because it's before Jerry threw the ball. Nobody cares about that. So we want to find this one over here. So we've done this. We already have this on our calculator. The only thing that I might change is I might go back to my window and I might change my y-min to -5. That way I can still see good old Jerry throwing the ball, but I can see a little bit below the ground because the ground is at 0. So then when my calculator prompts me as I use second trace 0, it's going to prompt me to go on either side of it. I can be on either side of it because I can see the other side. If you do that, you should get that at 25.856 feet. Now, last quiz, last test, some of you just insist on moving the cursor around on your own and trying to find it. You're not going to get the same value. That's why we're asking for 3 decimals, because if you're using the proper process, we all get the same exact thing. And so hopefully you're getting that same number. Okay, so I am going to quit. And hopefully this is help enough because we are just going to go ahead and move on. You have a 2-on worksheet. It should be review. There's literally nothing that we didn't learn last year. It's just digging the dust balls off of it and putting it in the forefront of your mind so that we can be ready for the fun stuff. The next few days, finding zeros, long division, synthetic division, and behavior, how many turns. We did that last year too. So it's just going to be so easy. You're just going to be amazed. Alrighty, happy Tuesday. Bye.